here just to teach you the basics of graphing exponential functions. To start with, I have a pretty basic function that hasn't been shifted to the left or right or up or down. It does have a stretch, however. Notice this a value right here. So to begin with, I'm just going to make a table. And I'll do the usual, like 0, 1, 2. I am going to throw a negative value in there, just to show you what happens. So I'll start with 0, it's a little easier. So 3 to the 0 is 1, times 2 is 2. 1 would get us, 3 times 2 is 6. 2 would get us 9, times 2 is 18. So we can start to see the pattern here, right? 2 times 3 would get us 6, times 3 would get us 18. We could obviously go backwards in that pattern. We could divide by 3. That would get us 2/3. And to just confirm that, if I substitute negative 1 in here, this 3 would become a 1/3 times 2. Yep, there it goes. We get us 2/3. Now notice, if I kept dividing by 3 to go backwards, let me just write these values down. So from 2/3, if I divide by 3, I get 2/9. Then I'd go to 2/27. What is 27 times 3 is 81. Notice that this value keeps getting smaller, but the numerator is just going to stay as 2, and the denominator is just going to keep getting bigger by a multiple of 3. This thing is going to approach 0. It's never going to get there, but it's going to approach it. I'm actually going to put in something called an asymptote, a horizontal asymptote to be precise, at y equals 0. Because I know the y values will be approaching 0 as x approaches negative infinity, right, as we go in this direction. So I know that I'm not going to ever cross that line. Let's put the values on the graph. We have 0, 2, 1, 6, 2, 18, that's somewhere up here. So we can see that this grows exponentially. And then the negative 1 2/3 is right here. As we go backwards, it's going to approach this asymptote. So every exponential function is going to have a horizontal asymptote. Like I said, this one's at y equals 0. That means if we ever see a exponential function that has been shifted up or down, that's going to change its horizontal asymptote. Let's try one. Look at this. This is looking pretty complicated. Let's take a look right here. Plus 1. We know that this got shifted up 1. Well, if the basic exponential function has a horizontal asymptote at 0, I'm going to say, that this has a horizontal asymptote, I'll just say it HA, at y equals 1. I'm going to graph that first. Just like that. Alright, you have a few options to make the graph here. Notice that we also can see a shift of right 3, right? Notice the x is being changed here. We're subtracting 3 from it. We could make a parent function table and then shift it, obviously, right 3 and up 1. Or you could just make a table that makes a lot of sense for this equation. So it's really up to you. A lot of people like to make the equation for the parent function. So let me actually, instead of putting y here, I'll actually write down what the parent function is. I would say it's 20 times 1/2 to the x. And I think 3 values is a nice way to go, or even 2. So if I substitute in 0, 1/2 to the 0 is 1. That gets us 20. So notice that this value right here seems to be the y-intercept. However, in this case, it's not the y-intercept, because remember, we were making the table for the parent function, and that value is going to get shifted, right? Look, it's going to get shifted two directions. It's going to get shifted right 3 and up 1. That y-intercept isn't a y-intercept anymore. So I just want to make that clear that that is actually not the y-intercept for the translated function. Another point, we could do 1. Let's see, 20 times 1/2 is really 10. Let's take those 2 points. Let's translate them. So yeah, do me a favor. Let's change the scale to go by 2 instead of by 1. So this would be 4, 6, this would be 8, 10, this would be 12, this would be 16, 20. And the x scale will be fine. So let's take the point 0, 20. We're moving it right 3 up 1. Right there. And let's take the next point, 110, which is right here. And again, we'll do it right 3 up 1. Be careful here, remember I changed my scale to 2. So it's right here at 411. And then notice that this graph is decreasing. This is called exponential decay. And notice that now it will approach the asymptote as x approaches positive infinity. So you can, like I said, do either way. You can make a table for the parent function, or you could have made a table, maybe like I would have used 3 for x, right? Because 3 would get us an exponent of 0. So it's completely up to you. What I always do, however, is I start with that vertical shift that tells me where my asymptote is, which actually now changes. And I can't erase the asymptote for some reason, so I would erase on yours. I'll do it in a different color. Remember, just because I changed the scale here. That asymptote is now at 1. So you want to make sure that your graph gets very close to that asymptote, but doesn't actually touch it or cross it. And that's how we graph exponentials.